Hey, future CUET toppers, and welcome. If you're ready to absolutely lock down the alcohols chapter and score some guaranteed marks, you are in exactly the right place. We're about to do a power-packed, high-retention deep dive that's going to make you a master of this topic, so you can walk into that exam feeling totally confident. You ready? Let's get into it.
All right, let's kick things off with a challenge. Look at this question right here. Can you solve it in 15 seconds? Go. Now, this isn't just some random question, you know? This is exactly the kind of high-stakes problem that can literally be the difference between a good score and a great one. Nailing this means you're already on the right track.
And that's exactly why this topic is so important. The alcohols chapter, especially the parts about reaction mechanisms, is an absolute goldmine for marks in the CUET exam. And I promise you, if you stick with me through this entire explainer, you are going to walk away with a deep understanding that'll help you across your entire chemistry syllabus.
So here's our game plan for today. We'll start with why this topic is so critical. Then, we're going to master the identification tests, break down the dehydration mechanism step by step, and then tackle some real exam questions. And what I think is the most valuable part, I'm going to reveal the top 5 exam traps that students fall for year after year. We'll wrap it all up with a rapid-fire revision. Let's get started.
Okay, let's officially kick off the CUET Alcohol Challenge. So why do I call it a challenge? Well, it's because while the concepts themselves are pretty straightforward, the questions are designed to test how deeply you understand them. And that's exactly where we're going to give you that edge you need to get ahead.
So, think of this slide as a little peek inside the minds of your exam setters. They're not just going to ask, "What is this?" No way. They're going to ask you to rank reactivity, to explain why something happens, or to predict the final product. And you know what? It all boils down to one single massive concept: carbocation stability. If you master that, you've pretty much mastered this entire chapter.
All right, time to play detective. So imagine this. You've got 3 mystery test tubes. One's got a primary alcohol, one is a secondary, and one a tertiary. How on earth do you tell them apart? Well, we have 3 key chemical tests to do just that. And trust me, CUET loves asking questions about these.
First up, we've got the heavyweight champion of identification, the Lucas test. The very first thing you need to burn into your memory is the reagent itself, a mix of concentrated HCl and anhydrous zinc chloride. This mixture has a special name, the Lucas reagent. Don't forget it. And here's the golden rule for this test. The reaction follows an SN1 mechanism. This one fact is the key to understanding everything.
Now check out this table. For a tertiary alcohol, what do we see? Immediate turbidity. That's just a fancy way of saying it gets cloudy right away. And why does that happen? The reason is right there. It forms the most stable carbocation. Think of it like this. A tertiary carbocation is super stable, like a perfectly balanced pyramid. It forms in a flash. But a primary one? It's wobbly and unstable, so it's way slower to form. Faster formation means a faster reaction. It's really that simple.
Okay, next up is the Victor Meyer test. Now for your exam, this one is less about the why and all about the what. It's a color-based test, and these results are straight-up identification points. Primary alcohols, they give a blood red color. Secondary, they give blue. And tertiary, they stay colorless. And don't you worry about memorizing this right now, because I have a foolproof trick coming up that's going to lock these colors in your brain for good. And our third method is oxidation. A primary alcohol will oxidize all the way to an acid. A secondary alcohol, it stops at a ketone. But the real star of the show here is the tertiary alcohol, which does nothing. It shows no reaction. And why is that? Well, just look at the carbon that's attached to the OH group. In a tertiary alcohol, it's already bonded to 3 other carbons. It doesn't have a hydrogen atom attached to it. And for this kind of oxidation, you need that hydrogen to get plucked off. No hydrogen, no reaction. Simple as that.
Okay, so we've figured out how to identify alcohols. Now let's see what happens when we start reacting with them. Specifically, we're talking about dehydration, which is just a fancy word for removing water to form an alkene. And you're going to see that the same core idea of carbocation stability is going to be our best friend once again.
For secondary and tertiary alcohols, this all happens through the E1 mechanism. So, step 1. The acid comes along and protonates the OH group. This turns it into water, which is a fantastic leaving group. Step 2. That water molecule says see ya and leaves, forming our good old friend, the carbocation. And finally, step 3. A base swoops in like a little thief and snatches a hydrogen from the carbon next door. The electrons left behind snap into place, forming a double bond, and boom,
You've kicked out water and made an alkene. So, quick question for you. Which alcohol do you think dehydrates the fastest? Think about it for a second. If you said the one that forms the most stable carbocation, you are 100% correct. The order is tertiary is faster than secondary, which is faster than primary. The logic is exactly the same as the Lucas test. A more stable intermediate means a faster reaction. This is a classic CUET reasoning question.
Now let's talk about something that trips up so many students, rearrangement. Think of carbocations like ambitious mountain climbers. They're not happy just being on a small, less stable ledge, like a secondary position. If they see a bigger, more stable ledge nearby, like a tertiary position, they will do whatever it takes to jump over to it. That's rearrangement, and it's a super important idea that often separates the top scorers from everyone else.
Okay, we have covered all the theory. Now this is where the magic really happens. We're going to turn all that knowledge into actual, tangible marks on your exam sheet with some clever memory tricks and practice questions. So, for the Victor-Meyer test, all you have to do is remember the acronym RBC. R for red, which is primary, B for blue, which is secondary, and C for colorless, which is tertiary. Easy marks, right? Now, grab a pen and write this down. This is your 4-step secret weapon for any mechanism question. 1. Check the alcohol type. 2. Think carbocation stability. 3. Apply the right logic, SN1 or E1. And 4. Check for Saytzeff's rule. All right, practice time. What do you think? Why does that tertiary alcohol react so fast? Take a moment. Okay, the correct answer is B. It's all because it forms a super stable tertiary carbocation. Option A is wrong because it's SN1, not SN2. C is wrong because tertiary alcohols are actually the most crowded, and D is wrong because this happens at room temperature.
And question number 2, what's the rule that tells us which alkene is going to be the major product? You got it. It's Saytzeff's rule. This rule just says that the more substituted and therefore more stable alkene is always going to be the main product you get.
All right, listen up, because this section right here could be the difference between a good score and a truly fantastic score. I'm going to walk you through the 5 most common traps that I've seen trip up even the smartest students. Let's make sure you're not one of them.
Trap number 1, confusing the conditions. Remember, Lucas is room temp, dehydration is hot. Trap number 2, and this is the big one, forgetting about rearrangement. Always check if a more stable carbocation can form. Trap 3, mixing up the Victor-Meyer colors. Just drill RBC into your head. Trap 4, applying E1 logic to primary alcohols. Remember, they prefer the E2 pathway. And trap 5, misidentifying the oxidation products. Primary gives an acid, secondary gives a ketone. Burn these into your memory so you can spot them on your exam.
Okay, this is it, the final lap. This is your 2-minute drill before the big game. Let's lock in everything we've learned today. This is what you should glance at just before you walk into that exam hall.
Go ahead and take a screenshot of this slide. Seriously, this is your golden ticket. Let's run through it one last time. Lucas test, immediate for tertiary. Victor-Meyer, remember RBC. Oxidation, acid-ketone no reaction. And dehydration rate, tertiary is the fastest. This is your ultimate cheat sheet.
Look, if you remember nothing else from today, please remember these 4 things. These are the absolute non-negotiable pillars for this chapter. Number 1, carbocation stability is king. It explains almost everything. Number 2, Lucas test is SN1. Number 3, dehydration is E1. And number 4, the major product follows Saytzeff's rule.
So, how did you do on those practice questions? Be honest. Drop your score in the comments below. If you found this helpful and you're serious about crushing this exam, then you're not just a student, you're on your way to becoming a CUET champion. So make sure you subscribe so you don't miss our next deep dive. Keep up the amazing work, and I'll see you in the next one.